Um, my questions were from the review sections that you posted. Can we do ones from those as well?
Yes. Let me go to it real quick. I have to got like 8 different tabs open here. So are you talking about the one that I circulated?
Yeah, you put one for each section, like, and it had reviews for section 5.5, 6.1
Oh, really?
like
Okay. I know.
separately.
I'm confused. I sent around a list of integrals in an announcement. Is that the one you're talking about?
No. Let me
Oh,
see where you posted it.
all right.
The
Because a
one
lot.
the one she's talking about are in the modules in Canvas.
All right. Give me a second
There's
here.
links to them.
Yeah. I those are not mine. Um,
Oh, okay.
so I've got module one open now. It's kind of confusing the way they do it here. Just tell me the name. Which one would you like it? I've got substitution rule, integration by parts, so on and so forth.
Um, it was the section, the integration by parts.
Okay.
Um, the one that I was having trouble with on that one is um number um 4 with the velocity. I just wanted to know if we were supposed to be able to recognize whatever that symbol is, that's the V to the lowercase, like subscript e, or because we
No,
haven't gone
you
over
know what?
that.
I hate to interrupt. I still haven't found
Okay,
it. It's
okay,
in
no problem.
modules.
It's in module 1 and it's under test review.
Oh, there we are, for Pete's sake.
So since there were no, the
Uh,
practice exams were only 5 questions, I worked predominantly on those because they
okay.
had been posted, and I thought that that was gonna. Before we used to get like three in calculus one, we got three like
Yes,
pre-test
yes,
practice
it's
exams, and
true.
we're not getting those here. So it's really
Right.
hard to gauge what's going to be on the test. So I thought this was more of a review of what was actually going to be on the test.
I apologize. Okay, so I've got it up here. So it's review sections 6.1, 6.2, 6.3.
Yeah, I have like one question circled from each one that I just did them over and over again, and I
All
wasn't
right.
getting
So which one would you like
the.
looked at?
So it was for the you had integration. For section 6.2,
Okay.
it was question number 2.
All right. I think I've got it. Um,
I eventually got that one right, but I had to look it up.
is it this
And
one?
yes,
All right. Sorry about that.
it's okay. I thought you posted them.
No. If you ever take 267, a lot of that stuff on there is stuff that I've created.
Okay.
But the 266, I'm using a lot of the stuff that was created by the other people. So I didn't even know it was there, to be honest. All right. So what are we doing here? We're doing integration by parts.
I think this
No,
one
this
was
one,
where we were supposed to do,
a
like,
trig sub.
yeah, the trig substitution,
Okay.
and then where we're supposed to know how to, manipulate them when you have sine or cosine to a degree, or tangent
Right.
to a degree. But
I'm changing my camera here.
the x squared in front of the trig sub threw me off.
Yeah. All right. Can you all see that okay? I mean, it's a little blurry, but can you see it?
I can.
All right. I just got to try to position some stuff here. Turn the light. There we go. All righty. Yeah. Tell you what I would do, you're going to want to know your three Pythagorean identities. Sine squared theta plus cos squared theta equals 1. Then if you divide through by cos squared, you get tan squared theta plus 1 is secant squared. And then there's a corollary to that one. Tan squared theta is equal to secant squared theta minus 1. And what you're basically looking at is the form that's underneath the radical. And the radical is a sum of two squares. And so it looks like we're going to want to use this one right here. Okay. The idea being is that if I can convert this into something that's a single squared item, I can get rid of the square root. So I need to make kind of a clever switch here. I need to say, let's let x be, and I just got to think ahead here. I want it such that I square it, I get a 25. So I'm going to let x be 5 tan theta. Okay. And so immediately I do the dx, which is going to be 5 secant squared theta d theta. And then I make substitutions, and I'll pause here just a second, but let me get the substitutions going. It's going to look like a mess for a few seconds. It's going to be, I'm going to have 5 tan squared theta. Oops, my bad. It should be square on the outside. And then radical 5 tan theta quantity squared plus 25. And then dx has to be accounted for. That's 5 secant squared theta d theta. And I'll pause here for a second and let you stare at that for a moment. Do you see how I made those substitutions? Made first of all made the decision here and then made the substitutions.
Yes, I do.
Okay,
I think I forgot the dx when I was doing it
that's
because then you
common.
simplified it.
Let's
Okay.
simplify this out. The radical part becomes 25 tan squared theta plus 25. Furthermore, that factors 25 parentheses tan squared theta plus 1. And furthermore, 25 tan squared plus 1 right here is secant squared. And that's all underneath radicals. These are all underneath radicals. So it really works out just to be 5 secant theta. We've gotten rid of the radical. So it's still messy. I apologize, but it's cleaned up a little bit. We've got 5 secant squared theta d theta. That's this guy on top now here. This guy's 25 tan squared. And then finally that radical got taken care of. It's just 5 secant theta. So it's cleaned up a little bit. And then I've got some cancellation. The 5's cancel. The secant takes care of one of these guys. And suddenly it's a rather simple integral. I bring out the 1 over 25 to the outside. And all I've got is a secant theta on top and a tan squared on the bottom. That still looks kind of intimidating, but it's a lot simpler. Okay. Um, and again, pop in if you have a question. It's kind of weird when we're doing this in the classroom, just kind of shout it out.
And
uh,
then on the bottom, then that would give us like u, and then on the top it would give us a du. So then we would have d like du over u. So then that should be ln of
well,
the numerator.
actually, unfortunately, I don't think that's going
Oh
to quite
no,
work here because if u is tangent, du needs to be
it would
secant
have to be
squared.
squared. Yeah.
And so here's where you start looking for other identities. For example, you know what I might try to do whenever I'm kind of in doubt is just convert everything back into sines and cosines. Um,
And we have one
let's see what
over.
happens when we do that. It's gonna look messy. Secant is 1 over cosine. Meanwhile, tan squared is sine squared over cosine squared. Let's see if that does anything for us. Um, it's going to give us, I'm going to flip over the bottom. It's going to be a cosine on top and a sine squared on the bottom. Let's see if that does that help us.
Cosine.
Um,
Then we get cosecant. That would be cotangent. And cosecant.
I'm not. I'm not so sure that helps me either. I'm looking for another way to unravel this.
Um, cosine over sine is cotangent, right? And then 1 over sine would be cosecant.
Yeah, that's right. Boy, those we're really getting deep now, aren't we? So
But I
cosine of
don't know how,
sine.
are we supposed to have those memorized for what then that, because that still doesn't give me a pair that I recognize as a, um, like a U and VU or any, do those match?
I think.
I, we haven't had
Uh,
to learn
yeah,
the
because we
cotangent
normally don't really
before.
deal with cotangents and cosecants.
Yeah.
Um,
I think that's why I had so much trouble with this one. First of all, I forgot the DX at the top when I was doing it. But then
yeah.
even when I was looking it up for help and I got it down to this part here, I couldn't figure out how I go from there. And their answer is in form of X because they've converted into X. So I didn't know how they got there. I liked practicing these review ones because it didn't have the help table, so I really had to struggle through them.
Actually, you know what? I see it now. Actually, you know what? No, no, I see it. Suddenly I see it. Boom, 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 boom.
Okay.
Yeah, forget that. Come down here. Suddenly it just dawned on me. Now it's a U du. Let U equal sine theta. Du is cos theta. It's all balanced. And we can do a power rule. This is going to be U to the negative 2. So we're going to integrate that. So it's going to be U to the negative 1 over negative 1. Oops, I don't need that anymore. Sorry for the mess. So when I clean up a little bit, it's negative 1 over 25 over U. And so it's negative 1 over 25. And U was just moments ago sine theta. Okay. All right. Sorry about that. Yeah, it suddenly just dawned on me. If you bring the sine squared up as sine to the negative 2, it's a U to U. U is sine,
Oh,
cosine, du is cosine. And you can do the power rule here. So just plus 1. So negative 2 plus 1 is negative 1. Divide by negative 1. And you get this. Okay. All right. We're back. I don't need that for me. And then the last thing we need to do is just convert that back into something useful. So if you recall from about 5 minutes ago, we let x equal tan, I'm sorry, x was 5 tan theta. Well, that means that tan theta is x over 5. So that means that going by the triangle here would be opposite would be x, adjacent would be 5, and hypotenuse would be the Pythagorean identity there. And then what I do is I just read off what sine is. Sine is going to be um, opposite over hypotenuse. So it's going to be, and again, just bear with the ugliness. That's what sine theta is. However, I could flip that, and that's what I get. And I hope that's correct.
that looks like their answer.
What's that?
That is their, that's what their answer looks like.
Okay, good.
Yes.
Well, it makes I feel good even. um,
Thank
yeah,
you.
you know what? I tell you what, these trig subs, I think really the goal here is just to get you guys handy with your trig because a lot of people forget their trig. When you get to math 267, we don't do these. We don't do trig subs. What we end up doing is we just end up um, we leave the function alone. We just change it into a different coordinate system, which makes it really easy. So yeah, these are rough. I'll admit, you have to make the right choice. If I go back up to here, you have to make the right choice based on the form of inside the radical. And um, here, I was just trying to unlock the thing inside the radical. So if I use this middle form here, 5 tan theta, that would eventually do it, which it did right here. And then from that point, you're just trying to kind of simplify things and hoping it works out. And I'll admit, I got to this stage right here, and I wasn't terribly sure what I had there. And even in this secant tan form, it doesn't really look very friendly. It actually is secant cubed. Uh, I'm sorry, I take that back. My bad. No. Am I wrong? I'm wrong. In this form, I just didn't recognize it. So I put it into sines and cosines, and then it still took me a moment to kind of see it. But suddenly I saw that it was a U to U substitution. So sometimes you just have to kind of power through these. Um, I hope this helped rather than muddled.
No, that was extremely helpful.
Okay. Well,
And seeing it where you took it from the like that's the other part, like, so when it's signed to the -2, like the reason we only had to multiply it by a negative was because that was a -2. Say that it was like a -3 or something like that, then we would have had to do the 1/2 times on the outside to the 25, right? Like I'm just trying to get all of those concepts in my
all right.
head.
So
Like if
where,
it was to a higher power
like
on
right
that
here?
last, yeah, or a lower power, like if it was like say -4 or
Well,
negative.
it's a power rule as long as this is not -1.
Yeah.
If
So,
it's
but
-1, it's a natural log.
since it was -2 and we were going up one, then it was just one. So that made it a negative. But we would have ended up with like a fraction that we would have had to multiply on the outside if that was a lower decimal, or say that it was a higher decimal, correct? Or I mean, a like less than -2, because then it would have gone to like from -3 to -2. So then we would have had to
Right.
multiply it by 1/2, correct? I'm just trying to get all of that when I'm like
If
doing
no,
when
no,
I'm
no, I see what you're
doing.
saying.
Okay.
The power here is
Like,
independent of what's inside here. If you had, if let's say I had a sine of 2x, which would just make this thing a nightmare, then I would have to do some
yeah.
balancing. But I didn't have that happen in this case. Um,
But if it was just like a -3, so then when we were doing the antiderivative, it was a -2. Then we would have to multiply by a -1/2 instead of a -1. Correct?
right.
Am I getting
Yes.
that right? So then you would
Yes.
end it up with like 1/50, like
Yes.
-1/50.
That is
Okay,
true.
I'm trying to get that in my head when I'm doing these substitutions, because I keep messing up the fractions when I have to multiply by a fraction and when I don't.
Well, the power rule, you always raise the power by one and then you divide by that new power. So
Yeah,
here I just illustrated by showing the -1 and the -1 twice.
and I don't want to take up any of your like all of your time. So if someone else
That's
has
all right.
questions, if you guys, yeah, if you guys want to, I mean, I have other ones from the reviews, but it seems like maybe these go a little bit deeper than what we're gonna have to do on the test. Like there was one
Basically, the
where,
test is going to be, it's not going to be a nightmare test, I don't think, at least for, it's just going to be one or two questions on each form. And,
okay,
pretty straightforward. It's going to look real familiar to you. In fact, the questions are chosen, many of the questions, I should say, are just chosen right from your homework.
okay, that's encouraging.
So
Um,
we throw a couple
there was
extras. There's a few mix and match type questions we throw in there, but
there
not
was there was one more on section 6.3 there, where the number 3 is a perfect square on the bottom, and I keep making mistakes when I'm doing them, where that, like, I get it when there's a over the partial fraction and plus b over the partial fraction, and then making that equivalent to the other side. When I ended up with they equal 0 because they're a over x plus 3 plus b over x plus 3, I didn't know how you get to like the 9 where you're substituting in x plus 3 minus 3 up at the top, or
Is it
what
one
they're
of these?
doing. So, yeah, I have the chat open. Yes, number 3.
All right. Let's take a look at this one. So it's the integral 3x squared plus 6x plus 9.
It's
The
still
bottom
showing
factors.
the oh, how do I get the mean
All right, I'm going to stop sharing here. The bottom factors. Oh, yeah.
I got, I got that, but then there's like a whole other step that you have to do. I'll
Yeah.
watch you because I didn't understand it.
Well, you can do partial fractions on this one, or you can do a substitution and let u equal x plus 3. So du is dx. There should be a dx there. But the cool thing about this is that x is u minus 3. Okay. And suddenly I make the substitutions. Let me just clean it up a little bit. Like that. And suddenly it's actually a pretty easy integral because I got a single denominator. So it's 3 over u minus 9 over u squared du. And I'll pause here. These are the substitutions that I made. This doesn't always work with parfrac because in this case, I was able to factor the bottom into a perfect squared binomial. Um, but in this case, yeah, just let me u equal x plus 3, du is dx, so there's no worries there. And then x would be u minus 3. So if I make the substitution there, suddenly it's two, it splits apart nicely. So I've got 3 natural log of u. And then this will be, we have to do the same thing. It's u to the negative 1. So it's going to be plus 9 over u. And we're basically done. 3 ln x plus 3 plus 9 over x plus 3. And I think that's
Now
all.
I see how they got there.
Yeah.
It, so you created a u, and then you solved u for x, and then you put that in as your u form for the top because we have x plus 3 on the bottom, which is our u, and then we have to figure out what x alone is.
It's kind of like we did a shift. Yeah.
Yeah. Okay.
Sometimes these integrals are like little puzzles. And you can use partial fractions on this one. It wouldn't be that bad. If you did partial fractions,
That's what I tried to do, but yeah, can you show us that way? Because that's what I was
yeah.
trying to do. But when I got to 0, I didn't know. So I got 3x, or so, yeah, so I did that, and then I got a times x plus 3a plus bx plus 3b equals 3x. So then I got a plus b equals 3, and I got 3a plus 3b equals 0. And then when I got to that, that's when I
Well,
tried using. Did I do that part wrong?
I don't know. Here's the partial fraction. There's a situation going on here. Um,
Oh, I didn't square the second one. That's what I did wrong.
yeah, you gotta do that.
So it's
So
a plus b, and it's over x plus 3 and x plus 3 squared. That would have fixed everything.
yeah, actually, this works out
Okay.
pretty fast. Oops, that's 6x plus 9 plus b, blah, blah, squared. And then ax squared plus 6ax plus 9a plus b, bottom squared. And then the main thing is that you take the parts with x, ax squared plus 6ax has to match up to 3. So a plus 6a. Wait a minute, hold on. I made a mistake. I even made this more complicated than I had to. I don't need to have a square here. So that'd just be ax plus 3a plus b. And that's going to match up to 3x. So that forces a to be 3. And now that a is 3, that we have 9 plus b has to equal 0. So b is -9. So suddenly the form over here becomes 3 over x plus 3, take away 9 over x plus 3 squared. And when you integrate that, you get exactly that.
Yeah, I wasn't squaring the second denominator, so that's why my partial fractions didn't work.
Okay.
I like it better the other way you did
I,
those.
I'm learning that apparently when I apologize, I don't see it on my end. When somebody else is talking, it doesn't go over the screen. Um, I don't know how to do that.
I know from the student end, they can just, if they right click on your name, they can pin it to the screen and it just keeps your screen up the whole time.
Okay, yeah. Why don't you guys all do that? Pin because I pinned my own screen up. I did not realize that was even an issue. I had no idea that was going on.
Hi, sir. On the previous problem, aren't both supposed to be integrated?
The one I just got done doing?
Yes, sir. Aren't they both supposed to be integrated?
Yeah, they are.
Okay.
This is the
Which means
final
they
one.
would be ln, right? Both of
Yep.
them?
Yep.
Okay. Because it would be 9 ln x
No.
plus
That's
or
ln.
that.
That's a power
Okay.
rule. That's
Oh,
power.
okay.
So this is an
Okay.
ln. This is a power.
The square root just disappears on the, no, I'm sorry, the squared would just disappear on the bottom for that, right?
Well, it becomes
And it becomes positive.
x plus 3 to the -2. And when you integrate
Oh,
that,
okay.
it's x plus, the 9's just on the outside. It's x plus 3 to -1 over -1. Actually, it was this negative. Okay, then two negatives make plus.
Yeah.
And then you have that.
Okay.
All right.
Can you work through on the test one that you sent out?
Yeah.
Question number 13.
All right, let's take a look at that one. I'm going to find it on my screen here. Look, again, I'm going to repeat. The test is 10 questions long, and about 6 or 7 questions were picked straight out of your homework. There's another couple questions that are a little more like mix and match or sliding, whatever they call them. So I think I don't want to sound like I'm kind of contradicting myself here, but sometimes these test reviews can be more trouble than they're worth because they tend to direct you in a direction you don't need to go. Um, it's basically just going to be a whole bunch of integrals. And then you have a couple at the end that deal with trapezoid rule and stuff like that. So I don't want you guys to get too worried about what to expect. If you've done all your infinity, you're gonna have seen all of the tests just about. So, all right, I'm bringing up the practice sheet. Give it a moment to come up. I'll share it here. Here we go. And which one did you ask for?
Number 13.
This guy right here?
Yes.
All right, let me copy it. This is a crazy looking one. Let's hope it works out nice. X squared plus 5x plus 3 on top. And then I've got x squared plus 4 quantity, and then an x squared minus 1 quantity on the bottom, all the x. All righty. So let's factor for us. Well, we can factor it one more time. X plus 1, x minus 1. And then what I'm going to do now, in this case, I really have no choice. I'm going to have to just work out a gigantic partial fraction. So what I'm going to do is I've got an irreducible quadratic and two linears. The irreducible quadratic gets a numerator that's a degree 1 less, so ax plus b. Each of the linears gets just simply a constant. Okay. And in fact, looking ahead, I'm going to show you how you can use uh, Desmos matrix to actually help us solve this guy. Okay. So that's what the partial fraction decomposition looks like. Now we're going to recompose it. We're going to bring it all back together. So we're going to remultiply all these parts together. So the ax plus b gets multiplied by x minus 1, x plus 1, which I can just abbreviate as x squared minus 1. The c gets multiplied by, my bad, x squared plus 4 and an x minus 1. And the d gets multiplied by x squared plus 4 and an x plus 1. Okay? And this, again, just hang in there. You can do this. This is going to be really ugly for a few seconds. What I need to do is I need to FOIL all this stuff out. Now, we can cheat sometimes, but no, I think I'm just going to show you the long official way. I'm going to FOIL everything out. It's going to be a long string of terms here. So it's going to be ax cubed take away ax, I'm sorry, plus bx squared, take away ax, take away b, and then here we're going to, okay, and then here we're going to have cx cubed, take away cx squared, plus 4cx, take away 4c, and then from the last, we're going to have dx cubed plus dx squared plus 4dx plus 4d. And that's all over the stuff on the bottom, which I'm just going to just do that and be lazy here. I have what here? I have 12 terms, and this all has to match up to the original numerator, x squared plus 5x plus 3. Okay? So what I'm going to do is I'm going to go by powers. I'm going to circle all my cubes. Now I don't have any cubes on the left side. So that tells me that A, C, and D have to make 0. Now I'm going to look at my squares. B, negative C, and D has to make 1. That's what's in front of the x squared. Now I'm going to look at my linears. I'll do squiggles for them. That's going to be negative A plus 4C plus 4D has to be 5. And then for the constants, which are just left alone, that's negative B, take away 4C plus 4D equals 3. Okay? I'll pause here, let you catch up. Does everybody see how I decomposed, recomposed, foiled, and then I'm basically matching coefficients. It's basically a 0x cubed, 1x squared, 5x, and 3. And there you see them right there. Okay. This is a matrix. All right. What I'm going to do is I'm going to write it in matrix format. Now, I'm going to have to do some zero filling. On the top, I have 1A, no B's, 1C, 1D, and a constant that's 0. On the second row, I have 0 A's, a B, a negative C, a D, and that has to make the 1. In the third row, I have a negative A, so it's negative 1. I don't have any B's. I have a 4C, a 4D, and that has to make 5. And then on the bottom, I don't have any A's. The B is going to be negative 1, negative 4, 4, and 3. All right. This is so cool. Does everybody see how I made the matrix out of this?
I do, but I don't know what you're going to do with it.
I'm gonna actually switch my screen here. I'm gonna go to give me a moment. I'm gonna go to Desmos because you're gonna get Desmos, and I'm gonna go to the matrix feature, and I'm gonna create a new matrix, and I have 4 rows and I have 5 columns, and the rows are going to be 1, 0, 1, 1, 0, 0, 1, -1. Find that negative. 1 and 1, and then third row is -1, 0, 4, 4, 5, and the bottom row is 0, -1, oops, -1, -4, 4, and 3. All right. Now here's the cool part. I'm gonna go to the next line, and I'm gonna go to RREF, matrix A, and there it is. There's my answer. And it gives me the form. I can press that little fraction thing, and I've got all what I need there. This is called row reduced echelon. If you just read the answers off the right column. The A is -1, the B is 1/5, the C is I'm sorry, +1/10, and the D is 9/10. Does everybody see that? You can do this on the test if you get a question like this.
So then we don't have to solve the system of equations. It just
No,
does it for us.
this would be a 4x4 system. You'd be here all night doing that. So you
Yeah, I
absolutely
did.
are allowed to use this matrix feature. I'm going to make it available. And so if you get a question like this where you get this massive matrix, do it this way. Okay? It's a huge time saver. If you were in my linear algebra class, yeah, that'd make you solve it out longhand. But no, in this case, I don't care how you find it, just find it. All right. So I'm going to unshare. So
Sorry, sir.
go ahead.
Sorry. Do you mind running us through how you got to the metric system again? This is first time seeing it, so I'm gonna
All
feel a
right.
bit.
Well, again, matching up the top row here with the original numerator here. The original numerator is this guy. After we fold all this stuff, I basically just matched powers. So all the cubes made this row here, and there was a 0x cubed on the left side, so it equaled 0. All the squares made 1. That's this row. All the linears make 5. That's this row. And all the constants, the here, here, and here, make 3. That's this row. And then what I do next is I create a matrix. Now, wherever I'm lacking a letter, I use a 0. So on the top row, I have 1A, 0 B's, 1 C, 1 D, and 0 constant. So I put a 0 in for the B slot. In fact, the columns are basically A, B, C, D, and then constant. Okay? So wherever you're lacking a letter, put a 0 in.
Okay,
And
thank you, sir. That's clear. But one other question: can you go back to the Desmos and show us how to get to the matrix?
yes, I'm not going to redo the problem. I'll just illustrate it here. You're going to type in new matrix, this key here, and you're going to tell it how many rows and columns. You need 4 rows and 5 columns. And then you just fill in the blanks. And then when you're done, hit this thing on the lower right, and then you go to RREF, reduced row echelon form, and then tell it to do that on A, and that calculates it all at once. It's a beautiful algorithm. If you're doing this by hand, it takes forever.
Okay,
Literally takes like 20 steps.
okay, so A is gonna be -1.
Yep.
B
B
is gonna
is
be 1/5.
correct.
C is
C
gonna
is
be 3/10, 1/10.
and D is 9
Then
over
D is
10.
gonna be 9/10.
Yep.
Okay, thank you, sir.
Sure. So I'm going to come back to here because this was the form I had it in. And I'm going to write it's going to be -x plus 1/5. And then we have x squared plus 4 plus c. And I'm not going to worry too much about appearances here. I'm just going to cram the fractions up on top. And that's really what I'm trying to integrate. In fact, I can split even this guy up into a pair. It's going to be negative x over x squared plus 4 plus 1/5 over x squared plus 4 plus 1 over 10 all over x plus 1 plus 9 over 10 all over x minus 1. And I apologize, it does look a little blurry. This is a natural log, and we have to do a little bit of balancing. It's going to be negative 1/2 ln of x squared plus 4. This 1/5 will just come out in front. Let's see if I can write that bigger. It's going to be negative 1/2 ln x squared plus 4. And then this one right here is going to be an arctangent. You have a 1/5 out in front. It's 1/5 times the arctangent. So you have to know this form. X squared plus a squared is going to be 1 over a, which is 2, and then arctan of x over 2. And then here you just got a couple of natural logs. You got 1/10 ln x plus 1, and then 9/10 ln x minus 1. And that is your glorious answer. Wow. And again, I'm going to look at my own key here. Did I get that right? Yeah. Holy smokes. No, I think I got it. Oh, I got some letters, or I may have made a mistake. I'm going to fix that. I think I did it right here. So, all right. Okay, guys. I know we're kind of hitting a lot here. I hope this is helpful. Um, let's see. Are the graphs where you can calculate the area of 6.5 on the test? Yeah, let's do one of those. Let's do one with right and left endpoints. I'll just kind of make up one.
Professor, so specifically the one on section 6.5 where it says use 4 rectangles to estimate of each type of area under a given graph of f from x equals 1 to x equals 9. I've probably done it 10 different times and cannot seem to get the right answer. So if you could go over that.
All right, where was that problem located?
It was section 6.5, question 5.
In Infinity?
Yes.
All right, I'm going to go there. Section 6.5, number 5. Come on, you. Okay. Let me share the screen. Okay, is this the one you were looking at?
It looks like it, yes. Although mine actually looks a little different. Mine is starting at the 1, but that looks similar to the help one.
Okay. They vary from, your questions will vary slightly. Every question has some random aspects to it. It's the same root question. For example, somebody else might get a graph that starts maybe halfway up and goes a little higher. It varies. I'm going to use this one right here. You've got an interval from 1 to 9. And so what I'm going to do is I'm going to split the interval between 1, 3, 5, and 7. So you know what? Let me just draw the picture here as best as I can. 1, 1, 3, 5, 7, 9. And again, my graph's going to be I'm doing it quick, so it may not be the most pretty graph. Something like that. All right, it'll have to do. All right. So the question is, for example, one of the questions is take the sample points from the left endpoints. Yeah, go ahead. Go ahead. All right. Well, I'll just go ahead and do it. So we want L4. So the left endpoints is 1, 3, 5, and 7. And if I draw it, this is terrible. I admit that this picture's not good at all. I was doing it pretty quick. Just eyeball it off the graph. Each has base 2, the rectangles base 2. So basically, you're just multiplying 2 times the height on each of these. I'm going to go back to my picture here, and I'm just going to eyeball it off the graph. Let me share it real quick. So at 1, it's 4. At 3, it's about 4.1, 2, 3. We're going to have to just eyeball it, about 4.2. At 5, that's 3, 5, that's going to be about 4.7. And then at 7, that's going to be about 5.5. And then that all I do is just add them up and multiply by 2. I factored out the 2 to the front to save myself a calculation.
I put it in the chat for those that was really particular about our estimated values, and most of them had 5 tick marks in between the y values, and that one has 8. So
Yeah.
you kind of have to gauge where you have to really zoom in, gauge where it is, divide 1 by 8, and then kind of multiply it by about where it is at the point that you're getting it. So
Yeah, I
it's
understand
just,
that. I do understand that that's an issue. Uh, the
yeah.
the the test. Give me a second here. I'm gonna check something. I'm not gonna share this. I'm just gonna look myself. Um, I agree. I don't think it's fair to have you guys all eyeball. Um,
Yeah, I was kind of going based off the numbers in the example. So if the example says like 0.3, I would use 0.3, but I don't know if that's the reason that it
and
was
that's
wrong
fine. You
because
know what? No, you're gonna have something kind of similar to this. You are gonna have to do some estimation. Don't worry about it. I mean, first of all, the system has some um, what's the word I'm looking for? It's we build in a little wiggle room. So obviously, if I look at I said 4.2 and somebody else said 4.3, clearly we have the right idea. Your answer is going to be slightly off, but it's still the right idea. So, I look at everybody's exam anyway. And if the official answer was 36.7 and you wrote down 36.8, I would give you credit because obviously you got the right idea. You're not going to get to that answer by accident.
Yeah, Pilates.
And
So
um,
off of
right.
those, like it asks you whether it's underestimating, and to me that's underestimating,
Yes,
correct?
this is definitely an
Now there
underestimation.
was a couple that I thought I understood was an underestimate and an overestimate, and it was like I ended up getting it backwards.
Yeah.
Um,
When the graph
so
is always like going up or down, it's usually pretty easy to tell. If the graph is doing a little of each, like it's doing up and down, like if you had something like this and you tried to split it up, that would be kind of hard to tell because sometimes they're going to be over and sometimes they're going to be above. All right.
I think in the homework there's a section where there's like 10 in a row where you're just figuring out whether it's overestimating or underestimating, and it
right,
gives you increasing, decreasing, concave, and convex. Like, and when you're doing that, there's a pattern there. It's like if it's increasing, the left value is going to be an underestimate. If it's decreasing, the right value is going to be an underestimate. Like they reverse, and then the concave and the convex um, graph, it's the same thing for when you're doing midpoints and the trig estimations. So if you just go back through those and like recognize that pattern, I think that that'll help.
You know, yeah, a lot of this is just kind of eyeballing it, trying to relate the increasing, decreasing concavities, like you just said. Um, Basically, the rectangles either go below or above, depending whether you're going right or left endpoints. One last thing I'll just mention, because I think it does come up. Make sure you know the trapezoid rule. I think that came up in here does like a number 6. So make sure you know your trapezoid rule. And the trapezoid rule, I'll just mention it, is I'll just do a graph here. Let's suppose I just had some dots. Let's suppose I'll just make an easy one. So what you do is you just draw trapezoids. You just connect the upper dots like that. The trapezoid rule would be, it's the base times the average of the two endpoints, so the left and right. So left height plus the right height. Okay. So you basically just, let's say here, this would be 3 and 5. So half 3 and 5 is 8, half of that is 4, and the base is 1, so it's 1 times 4, which is 4. And the second one would be 1, the base, and the trapezoid would be 1/2. This would be 5 and 4, so 5 plus 4, which is 9/2. So 1 times 9/2, which is 9/2. So yeah, just make sure you know the trapezoid rule. I always just found it easy on these. It's just that literally just draw them out, because otherwise you're just trying to. It's a lot of data. Just kind of. If I don't know, for me visually, I just had to draw it out. That was just me.
It was really easy doing it, the actual formula, because if you just follow the 2f(x) and stuff, it usually
That's
works
fine
out
too. So
And then
whatever works,
divide
just make
everything
sure
by
you know.
2.
Make sure you know your left, right, midpoint, and trap. The
Yeah.
LRMT, and you should be fine. So I'm going
I
to.
like that. I like that visual for the trapezoid rule though, because then if we forget whether it's the one that alternates like 1 2 2 2 2 2 or 1 2 4
Right.
2, it's easier to just visualize the shape, and then you can't make a mistake. if
I'm
you're
actually
using-
I'm actually not good at all with formulas. That's why I have to work it out. Because I make exactly those kind of mistakes. I forget something, or so I just have to work it out. But yeah, for the test, you want the left, right, mid, and trap. Make sure you know those 4. The questions themselves are not terribly complicated. They're about what you've already seen in your homework. There will be a couple of extra, I call them mix and match, and just kind of like I don't know how to phrase it, just like basically the same stuff, just phrased a little differently. But trust me, if you've been doing your homework on Affinity, you're going to be you'll have seen most of the tests, because I basically just pulled questions right off of the homework. So
For the question on 6.5, question 3, I don't know if you guys went over it, so if you did disregard, but I was wondering if there's going to be a question similar to that on the test.
no, I am not going
That one kind of hit.
No. And you know what? This will never ever come up again. Unless you become a math major and you are taking a graduate level course in Lebesgue integrals, you do not need to know this.
Which one was that?
Yeah, if 3 years from now, if you decide to become a math major and you see this question again, then give me a buzz. I'll help you out.
Thank you so much.
The whole idea behind something like this is, if you want to get the error to be small, just use thinner rectangles. I always thought this stuff was overkill. No, you do not need to worry about this. We're not. The test itself, you get 2 hours, but I don't think it's going to take most of you 2 hours. It'll probably take you most of you about an hour. It's not a very complicated test in terms of its structure. When you look at it, I think you're going to see, oh yeah, this is actually a pretty familiar question. A few integrals here, a few integrals there, some mix and match, and that kind of thing.
Professor,
Yes,
you mentioned the test is going to be 10 questions.
yes.
Do you by any chance care to say the split? It's gonna be more of use of or
Nope. I'm just
by
gonna say
parts?
it's all I'm saying is that if you've been working your homework, you'll be gently surprised.
Okay.
You'll be happy.
Okay. Thank you.
I don't want to give more detail. I want it to be a surprise. I want you to have that element of surprise, like you're opening up a Christmas gift or something. All
Okay,
right.
then for one last one, very good, Professor. For the partial credit that you promised, is it going to be just for
It
syntax error, or when you
it
like
depends.
you know?
I have to judge how you did the question. I don't have an easy answer to that. I look at everybody's test. I look at everybody's wrong answers. If I sense that your error was a plausible syntax mistake, I usually give you back the credit. If I sense that you were close, like on one of these types of questions, and the answer was 36.8, you wrote down 36.75, I would probably give you the credit. But I can't guarantee that. It's usually it's a sense, it's a judgment call on my part.
Okay.
Okay. It's going to take me a few days to do that. So after the test is done, I'm probably not going to have anything to you guys until the next weekend because it's going to take me quite a while to go through. I have 115 people. So it's going to take me a little while to go through each test, and I have to go through each of the videos. So I've got a lot on my plate.
That's extremely reassuring that you at least check our scratch work, though.
Yeah, well, if there's doubts, I will take a look at it. If you get the answer right, I'm just going to assume you did it right. I'm not going to look at your scratch work. But if
Hey, buddy.
yes, all right. Okay. Well, it is 4:05. I apologize I got on late. We've been on an hour now. I'm going to go ahead and power down here, and I'm going to get this thing recorded. It'll be on, I'll have a link probably in about an hour. The test is actually officially started right now. I don't know if anybody's actually tried yet. And, but, in the meantime, you are still welcome to post questions at Ed discussions from the homework. So if you see an Ed question or Edfinity, or even one of those questions you saw, like those practice test questions, you can post those to Ed discussions as well.
As far as the partial credit goes, like if you say that you had it all right and you messed up a negative sign somewhere, and so your answer is way off from where it's supposed to be, but it was because you made a minor error in your calculations, but everything else is right. Is it possible to?
Yes, it's a judgment call on my part. If I can.
Okay, perfect. Thank you.
That's all I can tell you. All right, you guys, I appreciate you hanging in there. Sorry for the confusing parts at the start. And again, good luck on the exam. And I'll be just in the background pretty much for the next few days. So 5, 4, 3, 2, 1.